All right, let's get right into it. We're going to talk about the invisible AI that you're using every single day, probably without even realizing it. It's called language modeling, and it is the engine that quietly runs so much of our digital lives.
I mean, seriously, take a second and think about it. You know when Gmail just knows what you're about to type? Or when Google Search understands your weirdly phrased question perfectly? Or when you have a conversation with ChatGPT that feels almost human? Well, guess what? It's all the same magic trick happening behind the scenes.
So here's our game plan for this explainer. First, we'll pull back the curtain on what language modeling actually is. Then, we'll uncover all the places it's hiding in plain sight. After that, we'll jump in a time machine to see how we went from simply counting words to truly comprehending them, figure out how we grade these things, and finally, we'll see how these AI superbrains can become specialists.
Okay, first things first. What in the world is language modeling? If you boil it all down, it's about one thing: teaching a computer the art of human language. It's like we're teaching a machine to talk, write, and understand just like us.
Now, the fancy term for this field is natural language processing, or NLP, and at its heart, a language model has one main job: prediction. It either tries to predict the very next word in a sentence, or it looks at a whole chunk of text and decides how probable it is. Basically, does this sound right? It just knows that "I am going to the store" is a bazillion times more likely than "I am going to the elephant."
And this is the perfect, simple example. The cat sat on your brain instantly fills in the blank, doesn't it? Mat, floor, couch. Well, that is exactly what a language model is doing. It's playing a giant game of fill in the blank, using the patterns it learned from reading a massive chunk of the internet.
Now, I know what you might be thinking. Predicting the next word? That's it? But that one seemingly simple skill is the secret ingredient that powers a shocking amount of the tech you use every single day.
Remember our first question? This is the answer. That auto-completion in your search bar? Language model. Google Translate? Yep. Siri and ChatGPT? Absolutely. Even your basic spell checker and that little red squiggly line for grammar, that's a language model too. It's behind summarization, speech recognition, question answering. It is literally everywhere.
So how did we get here? I mean, this stuff feels like pure science fiction. Well, the journey is an incredible story of how we went from computers that could barely count words to machines that can, well, kinda comprehend them.
You can really split the history into two big eras. First, there were statistical models. Think of them as simple accountants. They just counted how many times words appeared next to each other, but they had a tiny memory, only looking at the last few words. Then, everything changed with neural models. These aren't accountants, they're more like detectives. They learn deep, complex patterns and can grasp the context of a whole paragraph, making them way more human-like. This is where the famous transformer models live.
Yeah, the big problem with those older models had a nerdy name: the Markov assumption. But all that really means is that the model had terrible short-term memory. It's like trying to have a conversation with someone who can only remember the last 3 words you said. You can't grasp the full meaning of a story that way, and neither could they.
That memory problem is what kicked off the neural revolution. We started with RNNs, which were the first to have a sequential memory. Then came LSTMs, which were like an RNN with a serious memory upgrade, making them great for early chatbots. But the absolute world-shaking revolution was the transformer. Instead of reading word by word, it uses this incredible thing called self-attention to look at the entire sentence at once, figuring out which words are most important to each other. It gets the whole picture, and it's the brain behind every top-tier model today.
And what's really cool is that even within the transformer family, there are 2 different approaches. You have models like GPT, which are basically storytellers. They read left to right, and their whole job is to predict the next word, which makes them amazing at generating new text. Then you have models like BERT, which are more like editors. They're trained to fill in a blank in the middle of a sentence. Because they can look both forwards and backwards, they are absolute geniuses at understanding the deep context of existing text.
So, we've got these incredibly powerful models, but that leads to a huge question. How do we actually know if one is better than another? How do we keep score? I mean, it feels like every week a company releases a new model claiming it's the best ever. But how are they proving it? We can't just rely on a gut feeling that it sounds smarter. We need cold, hard numbers.
The most fundamental metric here is called perplexity, and you can just think of it as a score for how confused the model is. A high perplexity score means the model is constantly surprised by what word comes next. It's totally lost. A low perplexity score means the model is very confident and accurate. It's nodding along like, yep, saw that coming. So in this game, a lower score is always better. But perplexity isn't the whole story.
You need the right ruler for the right job. For machine translation, we use a blue score, which compares the AI's output to a translation done by a professional human. For summarization, there's a similar metric called rouge. And for tasks like figuring out if a movie review is positive or negative, we use classic metrics like the F1 score to measure accuracy. Different tasks, different scorecards.
And this brings us to our final, and maybe the most powerful idea of all. We don't have to just use these giant models as generalists. We can turn them into highly trained, world-class specialists.
This process is called adaptation, but pretty much everyone just calls it fine-tuning. The idea is brilliant. You take a massive model that has been pre-trained on the whole internet, and then you send it to grad school. You give it a smaller, super-specific data set to train on, like medical textbooks or legal documents. And that's how you turn a generalist into an expert.
The process is actually pretty straightforward. You start with a powerhouse like BERT. Then, you fine-tune it by feeding it nothing but, say, thousands of medical research papers. And what comes out the other side is a new expert model, like BioBERT, that now understands medical jargon and context in a way the original model never could.
And that's really the perfect way to think about it. You wouldn't ask your family doctor to perform brain surgery. You'd want a specialist. Fine-tuning is how we create those specialist AIs, whether it's for law, finance, or cutting-edge science.
And get this, it gets even wilder. This adaptation can cross language barriers. When you train a model on tons of different languages, it starts to learn the universal patterns of language itself. This means a model trained mostly on English can be fine-tuned to do complex tasks in French or even provide support for languages that have very little data online, giving them a huge boost.
So from just predicting the next word to becoming a specialist in medicine, the evolution here is just staggering. And it leaves us with this one profound question. As this technology continues to grow and master the one thing that we thought made us uniquely human, language, how is it going to reshape our world? What will it mean for our jobs, our creativity, and the very way we communicate?